In this video, we're going to look at simplifying trigonometric identities in the form of a cos x plus b sin x. Now, this example states, show that you can express 3 sin x plus 4 cos x in the form of r sin x plus alpha. So what we're going to do is we're going to write this out as the following, as 3 sin x plus 4 cos x, and we're going to use the identity that sin a plus b is exactly the same as sin a cos b plus cos a sin b. But we have an extra r in front of it, so it's going to be r times sin x cos alpha plus r times cos x sin alpha, if we were to expand those brackets using the addition formula. Now what we can see is that the coefficient in front of sin x is 3, and the coefficient in front of sin x on the right hand side is r cos alpha. So we can say 3 is equal to r cos alpha. And if we take the other case, the coefficient of cosine of x is 4, and the coefficient of cosine of x on the right hand side is r sin alpha. So we're going to say that 4 is the same as r sin alpha. So what we can do from there is to say, well, if I was to do r sin alpha divided by r cos alpha, that would give me tan alpha. So from there I can say that tan alpha, we know what r sin alpha is, that's going to be 4. And we know that r cos alpha is going to be 3. So we get that tan alpha is 4 over 3. So we can then say that alpha is arctan of 4 over 3. Arctan is exactly the same as tan inverse. So we can get that from our calculator here. So arctan and we're going to round that to 1 decimal place. That will give me 53.1 degrees. Put to 1 decimal place. Now, what we're going to do is we're going to square r sin alpha and square r cos alpha. So if we were to do that, we will get r cos alpha squared plus r sin alpha squared. Now in our case we know that r cos alpha is 3, so that's going to be equal to 3 squared, and we know that r sin alpha is 4, so that's going to be equal to plus 4 squared. So if I write this out in full, I get r squared cos squared alpha plus r squared sin squared alpha is equal to 3 squared plus 4 squared. But we can factorize r squared out. But we know a well-known trig identity that states that sin squared x plus cos squared x, or sin squared alpha plus cos squared alpha, in our case is 1. So we could say that it's the same as r squared. I'm just going to write it in so you're aware of it just for now for this example. So we can then say that r squared is 9 plus 16, r squared is 25, so r is the square root of 25, So we can say that r is 5. But if you go back to the question, they state we need to write it in the form r sine x plus alpha. So in the form of r sine x plus alpha, we know that r is 5, so it's 5 sine x, and we worked out alpha to be 53.1 degrees, so you put plus 53.1 degrees, and that's the form required. So for part B, we're going to use the identity that cos A minus B is cos A cos B plus sine A sine B. So in our case, 3 sine x plus 4 cos x. If you expand the brackets, you will get r cos x cos beta plus r sine x sine beta. So if we equate the coefficients, we can see the coefficient of sine x is 3. So we can say 3 is exactly the same as r sine beta. And we can say the coefficient of cosine of x is 4. And that's the coefficient of cosine of x on the right hand side is r cos beta. So we can say that tan beta is going to be 3 over 4. So we can say that beta is arctan of 3 over 4 is arctan 3 over 4, and that will give me 36.9 degrees to 1 decimal place. So now we're going to do the following as what we did last time. We're going to say that if we square r cos beta and if we square r sine beta, we know that r cos beta is 4, so that's 4 squared, and we know that r sine beta is 3 squared. So we can say that r squared cos squared beta plus r squared sine squared beta is equal to 16 plus 9. So in other words, we can say that take r squared out, cos squared beta plus sine squared beta, you know it's 1, must be equal to 25. So hence r squared is equal to 25. R is the square root of 25. R must be 5. But remember, we want it in the form of r cos x minus beta. So in our case, it's going to be 5 cos x minus 36.9 degrees. Here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Okay, welcome back. So we're going to express the following: sine x minus root 3 cos x in the form of r sine x minus alpha. Well, we know that the identity for sine A minus B is sine A cos B minus cos A sine B. So we can use that here to help us out. So it's going to be r sine x cos alpha minus r cos x sine alpha. Like so. So don't forget the coefficient of sine x on the left hand side is 1. So we can say that 1 is the same as r of cosine alpha. So 1 equals to r cos alpha if you equate the coefficients. And be careful, because you've got a minus here and a minus on the other side, we can say that root 3 is exactly the same as r sine alpha. So from there, it follows that tan alpha is sine alpha over cos alpha, and the r's cancel. So we can write that just for clarity, r sine alpha over r cos alpha. So what we end up with is root 3 over 1. So we will write that down. Tan alpha is root 3 over 1. Tan alpha is simply root 3. This is a well-known exact value that you should be familiar with. When you arctan that, you get 60 degrees if it was in degrees, but we're in radians. So 60 degrees is pi over 3. So it's arctan of root 3. And we're in radians, so that's going to give me pi over 3 radians. The little c means radians. So then we're going to do r sine alpha all squared plus r cos alpha squared. And don't forget, we got r sine alpha to be root 3, so it's root 3 squared plus, we said that r cos alpha was 1, so we can say r squared sine squared alpha plus r squared cos squared alpha is going to be 3 plus 1. So we get r squared as common factor, sine squared alpha plus cos squared alpha is equal to 4. So we can then say that sine squared alpha plus cos squared alpha is 1. So r squared on its own is equal to 4. R is the square root of 4. R equals 2. So we can say, therefore, we could write sine x minus root 3 cos x as follows: 2 sine x minus pi over 3.